Hi everyone, welcome to the low temperature thermochronology course. Today, let's have a look at the third section of this chapter, the external detector method. This lesson includes 5 topics as introduction of the EDM, procedure of the EDM, what should pay attention to EDM, disadvantages and applications of the EDM. EDM is the most common protocol for studying minerals with uranium content between different grains. In order to determine the uranium-238 content, the EDM requires that etched grains be sent to a nuclear reactor for thermal neutron irradiation. To measure the fission track age by the EDM involves determining the spontaneous track density in a selected grain and finding the mirror image area on the Muscovite external detector, where the induced track density is counted over exactly the same area. The sequence of preparing samples should follow the steps discussed in last lesson, including etching, attaching Muscovite external detector, package, irradiating, unpacking, adding alignment pinpricks, etching Muscovite, preparing EDM analysis mount, age calculation, and length measurement. Briefly, the spontaneous fission tracks are etched on an exposed internal polished surface on the grains, and the induced tracks on a Muscovite external detector attached to the grain surface during neutron irradiation. External detector is usually a sheet of low uranium Muscovite, commonly Brazil ruby, which is clear and free of inclusions, cracks, waves, and other defects, with about 5 ppb uranium. After irradiation, the external detector is etched to reveal an induced fission track mirror image corresponding to grains in the mount. Even though this results in a second set of tracks being produced within the grains themselves, these tracks will not be detected because they are not etched after irradiation. On grain mount, NS means spontaneous fission tracks counted on grain mount, and NI means induced fission tracks counted on mica detector. Fission track ages are calculated based on these 2 counts. dPa is measured parallel to the crystallographic c-axis. Measurement of track length and kinetic indicators as dPa or chlorine is an essential and important step for thermal history modeling and geological interpretation. Let's move to the third topic. What care should be done for the EDM? Because the geometry of track registration is not the same for the internal surface of 4-pi, on which the spontaneous tracks are measured, and the external detector surface of 2-pi used for induced tracks, a geometry factor must be introduced to correct for this difference, which is about 0.5 in most cases. A very careful selection of grains that with the highest etching efficiency surfaces as identified by sharp polished scratches is therefore essential for the EDM. Also, because ages can be measured on individual grains, a careful selection of grains can be made to avoid those which may be badly etched or contain dislocations. The most significant disadvantages of the EDM compared to the LASCP-MS method include the very long sample turnaround times, typically months, neutron irradiation, and laboratory safety issues arising from handling radioactive materials. Moreover, the procedure is highly laborious, with long hours needed at the microscope to measure the track densities and confine track lengths required for each sample. Even then, the number of counts and lengths are relatively limited, thereby reducing the precision of the measurements. The method also requires a major commitment to operator training, typically over a period of months, in order to develop the appropriate levels of expertise. In addition, the quality of measurements is significantly dependent on operator experience. Finally, the zeta calibration means the technique is dependent on other methods and therefore is not an absolute dating method in its own right. Though having disadvantages mentioned above, the EDM is currently the preferred dating method for apatite, zircon, and titanate in most fission track laboratories, as its high reliability for single-grain age calculation. Techniques of scanning electron microscope, electron probe, microanalysis, and electron backscatter detector are widely used recently when dealing with very low or very high uranium density minerals using the EDM. That's all for this lesson. Next time, we'll have a lesson talking about the LASCP-MS method, which is another widely used technique for fission track dating. See you then!